Alright, so today we're going to be explaining Cavalieri's principle. Basically the definition is that if two solids at an equal altitude, the sections made by the planes parallel to and at the same distance from the respective bases are always equal, then the volumes of the solid are always equal. That is to say, if you cut this in half and get a cross-section view of that and a cross-section view of this, and you multiply it by the height, then their volumes should be equal all the time.
Okay, today we are going to analyze this case. If we have 30 pesos on the top of each other, and we have this shape, we have to know the measures of the coin. One coin of 10 pesos has a radius of 0.4 centimeters and its thickness is 0.2. Okay. If we multiply 0.2 centimeters by 30, we are going to have 6 centimeters, and 6 centimeters is going to be our interval that will be from 0 to 6.
Okay, so basically we're going to compare the normal formula of a cylinder with Cavalieri's principle and integrals. So using the normal formula, we know that the volume for a cylinder is pi r squared times height. Our radius is 1.4 centimeters and our height is 6 centimeters. So when you do that, you get a total of 36.94 centimeters cubed. And now we're going to use Cavalieri's principle with integrals. So this is the integral. You're going to be running from 0 to a certain height that you don't know yet, right? And then you get the cross-section area of the figure. So we know that that's pi r squared and then dx. So you can think of this part as a constant because you know the radius and you know what pi is equal to, so you could take that out. Once you do that, you can get the integral of dx, and that's just going to leave you with x. So then once you find the integral of that, you substitute back in the constant right here, and you're going to get that it's going to be running from 0 to h, and you know that our h is 6. So right here, we're going to say that volume is equal to pi r squared times h minus the pi r squared times 0. This is going to cancel out and you're going to be left with the exact same equation as the normal formula. And once you substitute everything in, you're going to realize that 36.4 centimeters cubed is the exact same thing as the normal formula.
Thank you.
Thanks.